Hello everybody. In this video I'm going to be talking about mixture problems. How would you know it's a mixture problem if you were just seeing a random word problem? Well, it talks about combining stuff or mixing stuff, um, and it also gives you price times number of kilograms or jars or something. So we're going to set up a chart here, a mixture chart. And what is it? Number of what? Kilograms or pounds? No, this time it is jars. Number of jars times price per jar equals total cost or total price, something like that. Um, we'll say total cost this time. All right, setting up our chart. This time I think we're going to want 3 rows. So here we go, 3 rows. Splitting them like so. And we're talking about nuts. So they're both nuts, and so we'll call these $4 nuts and $6 nuts. And then mix. All right. How many jars worth $4 per jar? So that would be this one. Must be mixed with some nuts worth $6 per jar to get 50 jars. So we need 50 jars total worth $4.80 per jar. Okay, so we don't know this, so we'll do F for 4 and S for 6, and the total cost. So 4 times F would be the total cost of the $4 nuts, and 6S would be the um, $6 nuts. And for the total cost, it's kind of given. I mean, we have to do the quick multiplication here, but it's 50 times $4.80, which is going to be $240, I believe, because uh, four $4.80 times 100 would be $480, but since it's times half of that, it's $240. All right, so our two equations come from this and this. We have our cost equation right here and our number of kilograms or pounds or jars equation. So equation 1 is just F plus S equals 50. And equation 2 is 4F plus 6S equals 240. Now this can nicely set up into an elimination if this was a -4 or this was a -6. So either one of those would work nicely. I'm going to make it -4. So I'm going to multiply this top equation by -4. And that will get me -4F minus 4S equals -200. And then when I add these two equations together, I end up with 2S equals 40. And then when I divide both sides by 2, I get S equals 20. And then going back to this original green equation here, 20 plus 30 is 50, so F must be 30. And there we go. We can test that. First of all, 50 jars, that's easy. 20 jars plus 30 jars is 50 jars. For cost, the total cost of 30 jars would be $120, and the total cost of 20 jars here would also be $120, which would get you $240. So we're good. So how many jars? Okay, so we need 20 $6 jars, and we need 30 $4 jars. There we go. Success. All right, next problem. Again, we know it's mixture because we're combining stuff, and the word mixture is in there. So now we're combining cheese, and we're doing it in kilograms. So my chart's going to say number of kilograms times price per kilogram equals total price or total cost or something like that. Now I'm going to set up my chart. Alright, finishing up this chart. Oh, that doesn't leave much room, but we'll go for it anyway. Doggy, stop whining. Okay, so we're talking about Parmesan Romano, P and R. Okay, a food processing company produces grated cheese made from Parmesan Romano. Parmesan costs $3.50 per kilogram, 3.50, and Romano costs $5 per kilogram. How many kilograms of each type? So we don't know, so we'll put variables here, P and R. To produce 100, we need 100 kilograms, so that's the mix. And it needs to be worth $3.95 per kilogram. And so the total cost would just be the multiplication here, which is $395. And then the total cost for Parmesan would be 3.5p, and total cost for Romano is 5r. And so once again, same as last time, our equations come from the left column here. So we have Parmesan plus Romano equals 100. And we have 3.5p plus 5r equals 395. All right, so this is, we can set it up nicely for elimination if we give this maybe a -5 would be nice. So let's, we could give this one a -3, but either way works. So I'm just going to go -5, see what happens. -5. So multiplying equation 1 by -5 leaves us with -5p minus 5r equals -500. And then when we add these together, we're going to get, let's see, we're going to get -1.5p equals -105. Okay. And then we're going to have to do some division here, dividing by -1.5. So let's see, 1050 divided by 15 is, I don't know, let's see. Oh, that's going to go unevenly, I think. So 15 times 6 is 90, so 7. Let's see, 35, 3, yeah, so that's 105, so it's, yeah, that works. Okay, so I think it's 70, so P is 70, which would make R 30. Now we can test that. So 70 plus 30 is 100, so that works. And then, let's see, 3.5 times 70 is 210 plus 30, so 245. And then 5 times 30 is 150, and together that would be 395. Success. So, question, how many kilograms of each type of cheese? Well, 70 kilograms Parm and 30 kilograms Romano. All right, next problem. Okay, again, we know it's a mixture problem because we're mixing cereal. It says the word mixture. We're combining stuff. I think it says mixture. Yeah, mixed. Look at that. Okay, so we're mixing cereal, and we're talking about kilograms and cost. So it's going to be number of kilograms times price per kilogram equals total price or total cost or something. And set up our chart. See if I can get some straight lines, make it look incredible. It's not great. Oh, okay, okay. That's not too bad. Not too bad. All right, left side is Grocery Plans makes 2 types of cereal. The only description is the price. So we're going to call this the $3 and we're going to call this the $6, the expensive stuff. That's your Fruit Loops here, and that's your like Corn Flakes or something. All right, so number of kilograms for 3, let's make that T, and for 6, let's make that S. So grocery one that costs $3 per kilogram and one that costs $6 per kilogram. So the total cost of the $3 cereal is 3T, and total cost of the $6 cereal is 6S. And how many kilograms of each type should be mixed in order to have 15 kilograms for the mix? And we want to make it worth $4.80, and the total cost, is going to be the multiplication here. So, geez, let's see, 15 times 480. Well, $4.80 times 10 would be 48. Half that's 24. So it's 48 plus 24, which is 72. 72 bucks. Does that sound reasonable? I think it does. 72. So our equations are number of our kilogram equation. So T plus S equals 15. And then we have our cost equation, which is 3T plus 6S equals 72. Once again, very similar to the last two. If this T had a -3 or this S had a -6, these will nicely eliminate. So I'm going to multiply the top equation by -3 because, it's smaller than 6. Either way works, though. All right, so this top equation then becomes -3T minus 3S equals -45. Similar or same as the last two, I'm going to add them together to eliminate the T's in this case. So I'm going to end up with a 3S equals, let's see, 55, 65, 27? Is that right? 27? 27 plus 45? Yeah, okay. Dividing by 3 gives us S equals 9. And then putting that into this equation here, that means T must equal 6. And let's test it with the words. We're going to have 15 kilograms total. That works. The total cost for 3 kilograms cereal would be, in this case, 3 times 6, so 18. Total cost for 6S would be 54. 54, 64, 70. Yeah, so that works. We have success. So the question is, how many kilograms of each type of cereal should be mixed? So 9 kilograms of $6 cereal. Ugh, that's confusing because that says 6, but it's actually 6 kilograms of $3 cereal because it's the T representing 3. There we go. Thanks for watching.